Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, May-June 2022, paper 43. Let's start it. Question 1. A list of substances is shown. Answer questions about these substances. Each substance may be used once, more than once, or not used at all. State which substance is a product of respiration. We know that respiration is a process that happens in every living cell where the cell uses glucose and oxygen to produce energy, and the waste products are carbon dioxide and water. So the product of respiration is carbon dioxide. B. The main constituent of hematite. Hematite is the iron ore, which mainly iron 3 oxide. So the answer here is iron 3 oxide. An element which has a sulfate that is used to test for water. The test of water is done using anhydrous copper sulfate, which is white. When we add water, it turns to hydrated copper sulfate and it has a blue color. So copper sulfate is used to test for water, and the element is, of course, copper. A colorless toxic gas. We go back here to the last. The toxic gas is carbon monoxide. A reactant in fermentation. We know that we prepare ethanol by fermentation of glucose using yeast, so the reactant is glucose. A reducing agent in the extraction of iron. In the extraction of iron, we add carbon. Carbon burns in the presence of oxygen to produce carbon dioxide, and then carbon dioxide is reduced again by carbon to produce carbon monoxide. So the actual reducing agent is carbon monoxide. This is the reducing agent in the extraction of iron. Carbon monoxide reduces iron 3 oxide into iron and carbon dioxide. A conductor of electricity when solid. Here it is mentioned when solid to know that it has to be a metal, because ionic compound cannot conduct electricity when they are solid. Here the only metal is the list in is copper, so it's copper again that can conduct electricity when solid. A gas which is approximately 21% of clean dry air, so it is oxygen. Question 2. Here we have two isotopes of sulfur, 32 and 33. Use your knowledge about protons, neutrons, and electrons to answer the following questions. Describe how these isotopes are the same and how they are different. They are the same because they have the same number of protons, which are 16 protons, and the same number of electrons, which is also 16, of course. And they are different because they have different number of neutrons. We have the first isotope have 32 minus 16, so it has 16 neutrons, and the second one, 33 minus 16, it has 17 neutrons. So they are different because they have different number of neutrons. Why each of these isotopes has an overcharge of 0? Each isotope have a charge of 0 because the total number of proton with a positive charge is equal to number of electron with a negative charge, so they cancel each other out and the total charge will be 0. So number of protons is equal to the number of electrons. Why both isotopes have the same chemical properties? Because both have the same number of outer shell electrons, and we know that outer shell electrons is electron involved in chemical reaction, and that's why they have the same chemical properties. The sulfide ion S-2 have the electronic structure of 288. Why the sulfide ion has a charge of -2? By counting the total number of electrons, 2 plus 8 is 10, plus 8 is 18, and here we know that sulfur has 16 protons, so now number of electrons of sulfur is in the sulfide ion is 18 and number of protons 16, so the sulfide ion has 2 more electrons than the proton. That's what gives sulfide ion extra negative charge. Give the formula of an anion which has the same electronic structure as sulfide ion -2. An anion means it's a negative ion. To think about this negative ion, we have to know which groups that can form negative ions. We have group 5, group 6, and group 7. Of course, sulfur is in group 6, so we will think about element from group 5 or element from group 7. It has the same electronic structure of sulfur, so it has the same total number of electrons, 2 plus 8 plus 8. It will have 18 electrons after forming the negative ion. So we will go to group 7, search for group 7 can accept only one electron. It can form an anion with only one negative charge. So we will search in group 7 for an element that has 17 electrons, and when accept one more electron, now it has total number of 18 electrons, and it has the same structure as the sulfide ion. So the element which has 17 electrons is chlorine. Chlorine 17 can accept one electron, and it will form an anion with only one negative charge, and it has the same electronic structure of sulfur. Then again, we can think about one element in group 5. Group 5 can accept 3 electrons, so to reach to 18, we can search for an element with 15 electrons, and it can accept 3 electrons to reach to a total number of 18. An element with 15 electrons is phosphorus. Phosphorus is 15, 285. It can gain or accept 3 electrons to become total to a number of 18 electrons. Now it has the same electronic structure of sulfide ion, 288, with a charge of -3 because it's in group 5. Second part of the question about cation. Cation have also the same structure of sulfide ion. Cation means a positive ion. So we know that group 1 and group 2 can form positive ion. Now we need 18 electrons, so we can go to group 1. Group 1 lose only one electron and form an ion with only one positive charge, and group 2 can form an ion with 2 positive charges by losing 2 electrons. So we will first choose group 1, lose 1 electron, so we need an element with 19 electrons. So when lose 1 electron, it will be 18 like the ion of sulfur. The element with 19 electrons is potassium, 2881. When losing 1 electron, it will be 288 like sulfur. Another element from group 2 is calcium. Calcium is 20. When losing 2 electrons, it will convert also into 18 electrons like sulfur, the same electronic structure of the sulfide ion, and it will be 288. So now we have 2 examples for the anion which have the same electronic structure for the sulfide ion, which is phosphorus and chlorine, and 2 cations that have the same electronic structure of sulfide ion, which is potassium, and also we have calcium. Question 3. This question is about nitrogen and compound of nitrogen. Nitrogen molecule have the formula of N2. It has a very low melting point, very low boiling point. It is non-conductor of electricity and insoluble in water. Name the type of bonding in the atoms in a molecule of nitrogen. The type of bonding is covalent bond. Explain in terms of attractive forces between particles why nitrogen has a very low melting point. He wants the type of attractive forces, and the question is only for 1 mark. So directly answer using the type of the attraction forces. We have weak intermolecular forces of attraction between nitrogen molecules which don't need high energy to break it. That's why it has a low melting point. Explain why nitrogen doesn't conduct electricity. As we said before, nitrogen is a covalent compound. It has no ions, no free electrons, no mobile electrons, so it will not conduct electricity. Nitrogen reacts with hydrogen to form ammonia. We know this is the basic reaction in the Haber process. State the essential condition needed in the Haber process and write the equation for the chemical reaction. The condition of the Haber process is 450 degrees Celsius, 200 atmospheric pressure, and finally divided iron as catalyst. Then we will go to write the equation nitrogen plus hydrogen to give ammonia. You have to balance the equation and don't forget that this reaction is at equilibrium, so we have to draw the arrows of equilibrium. Ammonia is made in the laboratory by heating ammonium chloride with calcium hydroxide. Balance the chemical equation for the reaction. Okay, we will start here. Calcium is already balanced. Then we will go for nitrogen. Here, chlorine is 1. Here, chlorine is 2. So we will multiply this by 2. Now we have 2 nitrogen. So we will multiply ammonia by 2. Then we will count how many hydrogen. 2 multiplied by 4 is 8. And another 2 here. So we have 10 hydrogen. Here, 2 multiplied by 3 is 6. And we need 4 more, so we will multiply water by 2. Now we have 4 plus 6, 10 hydrogen. Let's check oxygen. Oxygen, 2 and 2, so this is already balanced. Hydrazine, N2H4, is another compound that contains nitrogen and hydrogen. Complete the dot and cross diagram to show the electronic arrangement in one molecule of hydrazine. Show only the outer electrons. Hydrogen has only one electron, so it can only form one covalent bond by sharing this electron. Nitrogen has the electronic configuration is 2, 5. It's in group 5. It needs 3 extra electrons, so it can form 3 single covalent bonds. So here, each nitrogen atom will form 2 different covalent bonds, one with each hydrogen, and the third one will be between the 2 nitrogen. As we can see here, each one form 3 different covalent bonds. Then, don't forget the lone pair of electron at each nitrogen atom. Ammonia and hydrazine are weak bases. Here is the reaction between one molecule of ammonia and one molecule of water. State what is meant by the term base. Base is a proton acceptor. As we can see here from the reaction, ammonia can accept 1 proton from water. So now ammonia becomes NH4, ammonium ion, with 1 positive charge. And water is converted into hydroxide ion with a negative charge. So ammonia is a weak base. It accepts a proton from water. Here, write the chemical reaction for between one molecule of hydrazine and one molecule of water. It's already mentioned here that hydrazine is like ammonia. It's a weak base, so it will react similarly to ammonia. Hydrazine will accept 1 proton from water. Now hydrazine is N2H5, and of course it will have 1 positive charge because it has 1 extra proton, and water will convert into hydroxide ion. Water here in this reaction acts as an acid. Why it acts as an acid? Because it donates a proton. An acid is a proton donor. So it acts like an acid because it donates a proton. Ethanol is made in industry by reaction of ethene with steam. The condition here is 300 degrees Celsius and 60 atmospheric pressure. We need a catalyst, and you have to know that the forward reaction is exothermic. State what is meant by the term catalyst. Catalyst is a substance that increases the rate of chemical reaction and remains unchanged at the end of the reaction. Here we have to complete the table using these words only: increase, decrease, or no change. We want to know the effect of increasing temperature on the rate of the forward reaction and the yield of ethanol, the equilibrium yield of ethanol. Of course, increasing the temperature will increase the rate of forward reaction. What about the yield of ethanol? Increasing the temperature of exothermic reaction, the reaction will shift backward to the endothermic side. So now the yield of ethanol will decrease. So increasing the temperature here will decrease the yield of ethanol. What will happen by decreasing the pressure? Decreasing the pressure, the reaction here we have ethene is a gas, steam gas, and ethanol is a gas. So decreasing the pressure, the reaction will go to the side which has the highest number of molecules or highest number of moles. So here we have one molecule plus one molecule of water. Total number will be 2 molecules. And on this side only we have 1 molecule of ethanol. So decreasing the pressure will shift the equilibrium to the backward side. Now the rate of the forward reaction will decrease, and of course decreasing the rate of the forward reaction will also decrease the yield of ethanol, because at equilibrium the equilibrium will be shifted toward the backward side, so decrease the yield of ethanol. Ethanol is a member of homologous series. Write the general formula of alcohol, the series of ethanol, CnH2n plus 1 OH. This is the general formula for all alcohols. State 2 general characteristics other than same general formula that all homologous series have. All the series have the same function group and the same chemical properties. One alcohol containing 3 carbon atoms is propane 1-ol. Draw the structure of other alcohol containing also 3 carbon atoms. Show all the atoms and all the bonds. This alcohol you have to draw have the same number of carbon atoms like propane 1-ol. So it is an isomer of propane 1-ol. Just to change the position of the OH group, now it is propane 2-ol. The OH group is on carbon number 2. This is carbon number 1, 2, 3. So here the OH on carbon number 2, it's propane 2-ol. When alcohol react with carboxylic acid, ester are produced. Structure of ester is shown. Name this ester. To know the ester, you have to divide it into 2 parts. The alcohol part here and the acid part. Of course, the acid part is the part that is connected to the carboxylic group. So this is the alcohol side. This is the alcohol side and this is the acid side. For the acid side, we have carbon 1, 2, 3, 4. So this acid is butanoic acid, and for the alcohol side we have 2 carbon only, so it is ethanol. So this ester will be ethyl, the part from ethanol, and from butanoic acid it will be butanoate. The name of the ester is ethyl butanoate. Here he want to know the alcohol and the carboxylic acid reacted to give this ester. It's ethanol and butanoic acid. We have ester Y that have the following composition by mass: carbon 58.82%, hydrogen 9.8%, and oxygen 31.37%. Calculate the empirical formula of the ester Y. First, we will write each element and the percentage of this element. Then, to get the number of moles, we will divide each element by its atomic mass. So we will divide the percentage of carbon by 12 and hydrogen by 1 and of course oxygen by 16. Now we have number of moles for each element. We will divide all by the smallest number. The smallest number here is 1.96. So we will divide all by 1.96. We have 2.5, 5 and 1. In empirical formula, we must change any decimal or fraction into a whole number. So we will multiply the whole ratio by 2. 2.5 by 2 is 5. 5 by 2 is 10. And 1 by 2 is 2. Now we have the empirical formula: 5 carbon, 10 hydrogen, and 2 oxygen. So the empirical formula is C5H10O2. Another ester Z has the empirical formula of C3H6O, and the relative molecular mass is 116. Calculate the molecular formula of ester Z. First, we will calculate the mass of the empirical formula. We have 3 carbons, so 3 multiplied by 12, 6 hydrogen, so 6 by 1 is 6, and 1 oxygen, so it is 16. The mass of the empirical formula is 58. And we have the mass, the relative molecular mass, which is MR, it is 116. So the relative molecular mass divide the empirical formula mass will give me 116 divide 58, it will be 2. That means that the molecular formula mass is double that the empirical formula mass, so we will multiply this by 2. Now we have C3, it will be C6, H6, it will be H12, and 1 oxygen, it will be O2. So the molecular formula will be C6H12O2. Question 5. The question is about copper in its compounds. Describe the bonding in metallic elements such as copper. You may include a diagram as part of your answer. Here, to draw a diagram of any metallic element, we will draw circles, arrange it in rows, and pack together in rows. This is the copper ions with a charge of positive 2 surrounded by a sea of delocalized electrons. And describe the bonding in a metallic element. We have to describe the metallic bond. It's a lattice of positive ions packed together, surrounded by a sea of delocalized or mobile electrons, and this lattice is held together by strong electrostatic forces of attraction, of course, between the positive ions and the negative electrons. Here, a metal spoon is electroplated with copper. A metal spoon is electroplated with copper. State what is used as the positive electrode and the negative electrode, and what will be the electrolyte. When electroplating any object, we have to know that the object to be plated is connected to the cathode, and the metal that we will use to plate with is connected to the anode. The electrolyte is made from the same metal of the anode. So the electrolyte here will be an aqueous solution of a soluble copper salt. It has to be soluble. So we can choose, we know that copper sulfate is soluble, so we can choose copper sulfate. Or if you don't know that the salt is soluble or not, we can always choose nitrate, because nitrate is always soluble. So the object to be plated is always connected to the cathode, and the metal is used to plate with is always connected to the anode. The electrolyte is made from an aqueous solution, soluble salt of the same metal of the anode. Here, the anode will be made from copper because we want to electroplate with copper, and the negative electrode will be the spoon, the object to be plated. The electrolyte is aqueous solution of copper sulfate or copper nitrate. The formula of crystals of hydrated copper sulfate is copper sulfate and 5 molecules of water. Hydrated copper sulfate is made by reacting copper oxide with dilute hydrochloric acid. This is the equation for reaction: copper oxide, sulfuric acid, and water. Here he gave me the volume and the concentration of the sulfuric acid, and we will heat the sulfuric acid in a beaker, then adding copper oxide until copper oxide is in excess. After that, we have to remove the excess copper oxide, and this of course will be done by filtration, removing copper oxide, because copper oxide is powdered or it is solid, so it can be removed by filtration. Then the aqueous solution has to be made heated until it is saturated and allowed to cool to form the hydrated crystals. Calculate the maximum mass of copper sulfate, hydrated copper sulfate crystal formed using the following steps. First, we want to calculate number of moles of sulfuric acid. As we said, we have the volume and the concentration. Number of moles equal to the volume multiplied by the concentration. Remember that the volume has to be in decimeter cube, not in centimeters. So we will divide 50 by 1000 to get the volume in decimeter cube. First, number of moles will be equal to the concentration, which is 0.2 multiplied by the volume 50 divided by 1000. Number of moles of sulfuric acid will be 0.01. As we can see from the equation, the ratio of sulfuric acid, number of moles of sulfuric acid to number of moles of the hydrated copper sulfate is 1 to 1. So number of moles of the hydrated copper sulfate is the same as the sulfuric acid, 0.01. Then here we have the molecular formula mass of hydrated copper sulfate is 250, and we want to know the maximum mass of copper sulfate formed. Again, we will use the equation of number of moles. Number of moles equal to the mass divide the molar mass, or the molecular mass here, MR. So number of moles is 0.01 and the MR is 250. The mass equal to 250 multiplied by 0.1. The total mass of hydrated copper sulfate crystal is 2.5 grams. Then we go to the next question. State one observation that indicates that copper oxide is in excess in step 1. In step 1, we add sulfuric acid in a beaker, heated. Then we will add solid copper oxide. We know that copper oxide in excess when it remains undissolved or unreacted at the bottom of the beaker. Step 1 is repeated without heating the dilute sulfuric acid. All other conditions are kept the same, but the rate of reaction decreases. Give a reason why the rate of reaction decreases and explain your answer in terms of particles. So here we have to explain what will happen to the particles if we repeat the experiment without heating and why the rate of reaction decreases. The kinetic energy of the particle will decrease and the particle will move slower, so fewer collision per unit time, and less particle will have energy equal to or more than the activation energy. So we will have a smaller percentage of particles which will make successful collision, and hence the rate of reaction will decrease. Name a substance other than copper oxide that can be added to the dilute sulfuric acid to produce copper sulfate. We can also use copper carbonate or copper 2 hydroxide to prepare copper sulfate from sulfuric acid. Name the process used to separate the excess copper oxide from the aqueous copper sulfate in step 2. Here copper oxide remains undissolved or unreacted, so undissolved solid can be removed by filtration. Suggest what is meant by the term saturated solution in step 3. A solution that cannot dissolve any more solid at this given temperature. Here we have two parts. The first part of the definition, solution which cannot take any more solids, this is for 1 mark, and the other mark for the word at this given temperature. So that's how can you get 2 marks for this question. The phrase heating to dryness means heating until no more water is given off. Explain why aqueous copper sulfate is not heated to dryness in step 3. Here in step 3, the aqueous copper sulfate is heated until saturated solution is formed and allowed to cool to form crystals. So we want to prepare hydrated crystals. So here we didn't heat to dryness because heating to dryness will form anhydrous copper sulfate and not hydrated crystals. Question 6. The periodic table can be used to classify elements. Group 1 metals react with cold water, while transition elements don't react with cold water. Give other 2 differences in chemical properties, and take care we will speak about chemical properties between group 1 and the transition elements. Group 1 metals have only one oxidation state, which is +1, while transition elements have more than one oxidation state. Group 1 don't show catalytic properties, while transition elements used as catalysts in chemical reaction. Describe the observation when potassium is added to cold water. Write a balanced chemical equation includes the state symbols. Potassium is highly reactive metal from group 1. It can react with cold water because it's highly reactive. Group 1 is called alkali metal because it is react with water to form alkali. Here potassium, solid, react with water, which is liquid, to form the alkali, which is potassium hydroxide, aqueous solution, and hydrogen gas produced. The observation will be the metal melts or disappear. We will have fizzing of a gas, and we may have fire or explosion, lilac flame, because the lilac is a characteristic color flame for potassium. Transition metals are stronger than group 1. Give other two differences in physical properties of group 1 metals and transition elements. So here we will speak about physical properties. The transition metals have higher melting and boiling point, and they also have higher density than group 1 metals. Some group 7 elements react with aqueous solution containing halide ions. When aqueous bromine solution added to aqueous potassium iodide. Aqueous potassium iodide is the aqueous solution containing halide ion. So the iodide ion here is the halide ion present in potassium iodide solution. So here we have the ionic half equation for the reaction. Iodide ions from potassium iodide loses 2 electrons. 2 iodide ions loses 2 electrons to form iodine. And these 2 electrons will be accepted or gained by bromine to form 2 bromide ions. Here we have to remember the reactivity of group 7. Reactivity decreases as we go down the group. So fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine. So the more reactive halogen displace the less reactive one from its salt. So here bromine will displace iodine from its salt potassium iodide. So when bromine reacts with potassium iodide, it takes the place of the iodide. Here we will have potassium bromide forming and the iodine solution. Here he wants the original color of the potassium iodide solution. We know that all potassium salts are soluble in water, so potassium iodide will be soluble. The aqueous solution of potassium iodide is colorless. The final color of the reaction mixture, iodine in water, has a brown color, so the final color will be brown. State the name of the general term given to this type of reaction in which electrons are transferred from one species to another. Here, the electrons are lost from iodide ions and gained by bromine. So, lose electron and gain electron in one reaction means oxidation and reduction in one reaction. This is a redox reaction. Identify the oxidizing agent in the reaction. Give a reason to your answer. The oxidizing agent here is bromine. Oxidizing agent is a substance that oxidizes other substance and itself get reduced. So here we have to know that bromine get reduced. How? It accepts 2 electrons. It gains 2 electrons. So it is oxidizing agent because bromine is reduced. It gains 2 electrons, or because the oxidation state decreases. The oxidation state of bromine changes from 0 to -1. So it decreases means it is reduced. Use the key to complete the table to show the result of adding aqueous halogen to aqueous solution of halides. One has been completed for you. Okay, we will again speak about the reactivity. Reactivity decreases as we go down the group. So chlorine can displace bromine from its salt or from its halide solution, and bromine can displace iodine from its halide solution. So here chlorine can displace bromine from potassium bromide and can displace iodine also from potassium iodide. So we will put check mark here for the first row. Then bromine cannot displace chlorine because it is less reactive, so this will take X mark. Then bromine can displace iodine from potassium iodide because it's more reactive than iodine, so here we'll put check mark again. Iodine is less reactive than both bromine and chlorine, so it cannot displace any of them. Here we come to the end of our exam. Comment down below if you have any question. Subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.